For this problem, they want you to find the absolute extrema of the function on the closed interval. So you have your function, you have your closed interval. So the first thing you want to do is make sure it's continuous on this interval. So you look at it and it's just a cubed and a squared. So there's not going to be any holes or asymptotes. So we're good there. The next thing is when you take the first derivative, you set it to 0 or does not exist. So you see if the function will equal 0 at any place, or if it does not exist at any place. So once we take the derivative, we set it to 0. So since we have 3x in both of these, I can pull that out, because if you just multiply it across, 3x squared minus 3x, so this equals that. So now we can set each of these to 0, so 3x equals 0, x minus 1 equals 0, so x equals 0 and x equals 1. Make sure that both of these points are in your interval, because that's an easy trap that they would like to put in. So, but both of these are in the interval. And does this function the same thing? Is there any place where it does not exist? So since there's no place that this could not exist, we don't have to worry about that. So our two things are x equals 0 and x equals 1. Now, when you find these things, these are called critical points. When you find these things, you plug it back into the original function, and you also plug these into the original function. So why do we plug it into the original function and not the derivative? We plug it into the original function because since we're finding the absolute extrema, we want to find it on the absolute extrema of this function. This is the derivative. This is a different graph. We want to know where the absolute extrema are on this graph, the actual function, not the derivative, but the actual function, because these two have different graphs, but we want to know where it is on the original graph. So that's why we plug these, the critical points, and the endpoints on this function. So that's what I did here. All I did was all 4 of those points, I plugged it in, and then you plug it into the original function, and you get these numbers. After you plug everything in and do the arithmetic, you look for the smallest and the largest numbers. This will give you your absolute min and absolute max. So which ones are the smallest? So right here we have negative 40.5 and we have positive 40. So this one's the smallest and this one's the largest. That means that at x equals negative 3 and it will be our absolute min, and at 4 it will be our absolute max. And that's our answer. Since all you do is you look for the largest and smallest number, and that'll give you your answer. So to recap, what we did was we take the function, we just take the derivative, set it to 0, we take those critical points, plug it into the original function, we plug the endpoints into the original function, we look at the largest and smallest number, and that will give us our absolute min and absolute max, which is x equals negative 3 and x equals 4. I hope that helped, and thanks for watching.